You are looking at number 15 from your Rationals study guide. This is, notice, addition. If it is addition or subtraction, you must find, let's say it together, common denominators. Okay, so I'm looking at those denominators. I cannot tell hide nor hair about them because they're not factored. So that's the first thing, is you're going to rewrite these. Just rewrite the numerators. You're not going to mess with them at all with addition and subtraction until toward the end. What you've got to do, though, is you've got to factor your denominators. Well, first of all, k minus 1 is totally factored. So I'm going to put it right there. Remember that an entire numerator or an entire denominator has implied parentheses, and it is highly helpful to go ahead and put them on there so that you can see that that's all one tight little nugget of data, not two individual things in terms of how we look at that. All right, but what I've got to do here, and I'm just going to do it down here, is I've got to factor this. I notice there is no GCF. Only 2 of the terms have K's, and 5, 2, and 3 don't share a common factor except for 1. So factoring by GCF isn't going to help. I know that you know that what you've got to do has to do with figuring out factors of negative 15 that will somehow combine to give you that middle term, negative 2. Now, take your time, go over here and list the factors starting with 1 and 15. 1 times 15 is one way that you would get a negative 15, or a 15, and we'll figure out where the negatives go in a minute. But if you add or subtract those, there's no way to get a 2. So I know that that's not it. 2 does not go evenly into 15. 3 times 5 is a factor of 15. 4 doesn't go into 15, but you know that anyway because 2 didn't go into 15. If 2 didn't go, 4 won't go. And then 5 times 3, you've looped back around, which means that your complete factor list you already had up above. Okay, so you're looking for a 3 and a 5. You've got to get it to be a negative 2, which means the negative is going to go on the 5. Now, I factor by grouping. I know y'all do that, the X thing. Well, I don't know that, and so I'm going to show you factor by grouping. Factor by grouping is where you take the first term and rewrite it exactly as it is. You take the last term and rewrite it. What you just figured out is how to rewrite that, the negative 2k. And in this case, I'm going to rewrite it as negative 5k plus 3k. You will notice that if you were to combine those, it would give you negative 2k. So you've just written a true statement and equivalence underneath that. Now, here's the whole point of factor by grouping, and that is that you group 2 and 2 and factor them. So in the first pair, I get a 5k as a common factor. If I take that, it ends up being a k minus 1 in parentheses, plus the second group is a 3 as a common factor, and I end up with k minus 1 in parentheses. Once I've replaced the work that I've done, I mark through it so I don't get confused. Now, I am going to take, you will notice that both of these have k minus 1 as a common binomial factor, which I essentially undistribute by moving it to the front. So I'm going to bring k minus 1 to the front, and what's left if you take k minus 1 from those two terms is 5k plus 3. Now I've replaced that. So now everything is factored in the denominator. This allows me to see I have who has. Okay, looking at k minus 1, this first arrogant little rational expression says I have a k minus 1, and the other one says I have a k minus 1 also. And then the first one says, well, I have a 5k minus 3, and the second one says, uh-oh, I need to get me a 5k minus 3. Well, the only way you can do that mathematically is to multiply by 1, or at least by kind of a messy version of 1 that will allow that to happen. So even though 5k plus 3 over 5k plus 3, that's really just multiplying by 1. Look what it did now. it gave that second term of 5k minus, or 5k plus 3. So they both now have common denominators. Now my strategy that I like to use at this point is I know the common denominator. I go ahead and write it. I don't want that line that big. I'm going to write a line, and my common denominator is k minus 1 times 5k plus 3. You only write it once. So now you just have to do the simplification in the numerator. I'm going to rewrite k squared minus 10k plus 1, and then 1 distributes across there, which basically just means plus 5k plus 3. Okay, you're going to combine like terms where it is possible to do so. So looking at this, that k squared right there, I don't see anything that's a like term to that, so this is equal to k squared. By the way, I'm going to go ahead and write my denominator again. Notice that I rewrite a lot, and that's okay. In algebra, it's the idea that you're slowly morphing from one thing to another thing. So that's all right. Get used to it. That's how you get it right. Plus 10k plus, actually that's minus 10k plus 5k. If you have a negative 10 and a positive 5, that ends up being minus 5k. And then lastly, I've got a plus 1 and a plus 3, which gives me a plus 4. Notice that I do triangles, circles, squares for like terms. That's just a strategy to let you know the things you've already used and which things match. So I've got k squared minus 5k plus 4. I'm very nearly done. I'm pretty sure that something might factor in the numerator. So I'm going to rewrite this as factors. I'm looking for two numbers which multiply to give me a positive 4, but add to give me a negative 5, and I'm pretty sure that's going to be k minus 4 times k minus 1. Correct? Because they multiply to give me a positive 4, but if you add them, you get a negative 5. And then that's over k minus 1 times 5k plus 3. Now it's slash and burn time. K minus 1 over k minus 1 simplifies. The other two just don't. Remember that with fractions, it's all or nothing, and simplifying when it comes to binomials. So k minus 4 over 5k plus 3 is your solution. Put a big circle on it and a smiley.